So I will be talking today about, I called the presentation Sustainable Spatial Innovation. And I was supposed to do this as a geo presentation with Eduardo Diaz, who is a researcher in the same research group as Henk and I, but also works at GEODAN. I only work for the VU. I want to talk to you about a special spatial innovation that we are working on with a lot, and it's called Minecraft. I will quickly show how Minecraft fits within geospatial information and the environment. This is the graph that shows my PhD research. My research project is called 3D for Environmental Modeling, and my hypothesis is that there are 3D methodologies that can facilitate the energy transition. And when I talk about 3D methodologies, I'm talking about data. So there's 3D data that you can implement in very many different levels of detail and quality. There's 3D models. Of course, for a 3D model, you need spatial data. But for instance, for data, you can use BIM models or just blocks of buildings. And for models, you can do the same. So you can do very simple simulations, or you can make it more complex, do more assumptions, and do more measurements when you have big data. But also you can use machine learning, a term that came around. So these are all things that I'm looking at in my thesis. And what I want to talk to you about today more is the second part of this graph, is the visualization and the acting part. Because 3D methodologies seem to be always useful, but it very much depends on how you present them, and especially to who you present them to. And for certain people, 3D methodologies might not be quite as useful because they might even be very confusing, while several tools might be actually specifically very useful for these people. And the people I want to talk to you about today is children. And what we want to do is we want to move any person, but especially children, to act in the future. And so we need to create awareness, and we need to inform them by select the data, choose models based on knowledge level, because we can have very highly advanced models, but if people want to understand what they're looking at, and we use highly evolved models, or very complicated key performance indicators, we can explain them a lot, but they won't understand. So we need to be strategic about this, not in a sense of influencing, but more of reaching out to people. And finally, we need to visualize it in an attractive way. And that can, again, be very difficult for a policymaker who works very high in the Dutch government, or when you're a child. And one of the things that we are experimenting with a lot is serious gaming. Because to create awareness, you need to not only make it a task, something you have to do, but you have to make it fun, such as by making it into a game. And the idea, in the end, is to bring stakeholders and ideas together. And this is, So why children as a stakeholder? Because generally when you look at literature, they are very much overlooked. We think of business owners, citizens in general, but usually mature citizens, politicians, governments, but usually children don't really come up. Well, education of all stakeholders is important, and children, first of all, they live here, and second of all, they are the ones who need to follow us. The second is that in the in the Convention of the Rights of the Child, it explicitly talks about education of children in the environment. So it's actually something that we oblige ourselves to engage in. And then what are we going to do? So what did we design? I'm going to assume everybody knows about Minecraft. If you don't, it's like Legos, but then you can do much more cool stuff with it, and it's digital. So Minecraft is a big gaming environment with which you can do all kinds of cool stuff. And together with GEODAN and the GeoFort, we developed GEOCRAFT. I will show pictures of that in a minute. It's actually the whole of the Netherlands in 3D in Minecraft. So you can really go to this building and you can see it in a rough shape. And then there's ECOCRAFT, which is going to be what I'm going to tailor towards in this presentation. So that is where we move towards having environmental models connected to the Netherlands or to the real world that we modeled in GeoCraft. And finally, a specific application that I developed, which is energy craft, a lot of crafting. So this is GeoCraft. If you look at it, if you produce the Netherlands in 3D, it looks like this. However, so what you pretty much see is you see roads and you see buildings, and based on the point cloud, AHN2, the Dutch height file, and basic topographic data, this was produced initially. And the challenge of GEOCRAFT is actually to challenge children to make it look more like this. So to create the environment as it actually is. And actually lots of children are still playing this game at this moment, and even some larger children, let's call them that. And so there's very many different kinds of geospatial data that can be included in this. So land use data, but also transport infrastructure and subsurface information. So here you can see the actual subsurface layers of Amsterdam. This is Amsterdam. And what I think is really cool is these are the actual tubes of the new subway that they're still creating in the Netherlands, in Amsterdam. And we can include geospatial processes such as energy, air pollution, and waste management. And we first started using this, apart from to develop the situation as is, in Amsterdam as well, by educating children in spatial awareness. This is an area in Amsterdam that was desolated and didn't really have a lot of a future, and the city wanted to redevelop it, and they challenged children of a school that was located very close to come up with a spectacular design. And this is one of the designs. And there was one common element that each of the plans of these 14-year-olds had, and that was they all wanted a library. And then finally, how do we engage them? So we decided to combine environment with GeoCraft, and we came up with ECOCRAFT. So this is one example of a sound model integrated within the Minecraft environment. It's of course a meter by meter by meter, so the granularity is not spectacular, but it does give insight in a way that people usually understand. And so you can see clearly the impact of the sound decreasing the further away you get from the location, and also slightly, but that's a bit more difficult to spot, the impact of the height difference. And this is one of the results of energy planning. So you can see the white, those are buildings that are insulated, and the other specs are solar panels. So the goals of ECOCRAFT is to create sustainable awareness in a fun way. We include serious gaming elements, but also impact assessment. So we wanted to have quantitative data included in this to have children, but other people as well, have an impression of the consequences of their decisions straight away. And it enhances the involvement of citizens in general and children in specific. And with EnergyCraft, we designed a serious game to teach about energy in the built environment. Youngsters are playing in teams to redesign the energy situation in their neighborhood. We've done a case before for this. We had 100 children spread out over 4 classes between ages 14 and 16 come together to play Minecraft. And this is the final winning design. Well, actually a small part of it, because they had quite an area to design. This is the infrastructure that we used. Because in the beginning, it was quite complicated to make this all happen, and schools, not all schools are technologically already very far advanced. So we had the basic environment, and the children were challenged to come up with a new design. We took out the point cloud, because actually below Minecraft there's a point cloud. We put it through a spatial model, and we got the scores, and we fed them back to the children and gave them advice on where they made poor decisions and where they made good decisions, and they continued on designing. And they had feedback for themselves inside an Excel sheet, because we couldn't provide them with all the spatial data they needed, so this gave them a good indication of what good and bad choices were. And this iterative step is very similar to what the framework of Karel Steinitz in the geodesign process also advocates. We gave them a couple of game rules, so they were allowed to place urban wind turbines, PV panels and insulation, and instructions on how to do that within the game. So this is how they placed insulation. They had to strip the building of its roof, which is orange wool, and had to replace it with white wool. And it looked like this. And these technologies performed on 3 key performance indicators. They had an investment cost associated with it. CO2 emissions were avoided, and energy was either saved or produced. And based on these 3 indicators, they could generate a gaming score. So first we normalized to 1, and the investment cost had a negative impact. And finally, in the end, they could only get a score of 1, and many 14-year-olds don't really like that, so we made them, we multiplied by 1,000,000. And finally, the winning team wins a 3D printed wind turbine. We're making some small improvements now, so this is what it originally looked like, but now there's a new Dutch file on land use. It's called the BGT, and so now it looks much more familiar, so you see walking paths and cycling paths and things like that. And we're going to do in-game modeling, so now we had the very complicated infrastructure, and now they're going to get direct feedback in the game. So in conclusion, the game actually worked to extract information and ideas from youngsters, a group that is very difficult to explain all these difficult concepts to, and it made them very enthusiastic to participate. I overheard some kids saying, I have to go to physics class. Oh no, I don't have to go to class because I'm going to play Minecraft. And then it also helped to teach them very difficult concepts, and the point cloud that they built can be used for different analyses further back. So, thanks.